Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one type of question, write a quadratic in vertex form, cost more students marks last year than almost any other on the higher paper. And the reason isn't a tricky idea. It's one small algebra step that gets forgotten. Stick with me for the next 12 minutes and you'll walk away able to convert any quadratic into vertex form and collect the marks the examiner is handing out.
Sound familiar? I remember staring at the paper thinking the answer should be easy, but my working lost me the marks.
The concept, why we complete the square and how it works. Start simple. You have ax squared plus bx plus c. Completing the square rewrites that as a x plus p squared plus q. Why do we do this? Because the form tells you the vertex of the parabola directly, and it makes solving some problems much cleaner. More importantly for exams, it's a repeatable method that gains method marks when shown clearly.
Step 1. Factor out the leading coefficient a from the x squared and x terms. That gives a times x squared plus b over ax plus c. Don't touch c yet. We'll complete the square inside the bracket because it's simpler when the x squared coefficient is 1. This small factoring step is where many students trip up. If you forget to factor a, the numbers inside the square will be wrong.
So always pull out a first. Got it.
Step 2. Take half of the coefficient of x inside the bracket. If inside you have x squared plus bx, then half of b is b over 2. Square that half. That's the number you add and subtract to complete the square. It's not a magic formula, it's algebra. X plus b over 2 squared expands to x squared plus bx plus b over 2 squared. Showing that arithmetic is exactly the kind of method the examiner wants to see.
Let's do a simple worked example first. X squared plus 6x plus 5. Half of 6 is 3. Square that to get 9. Rewrite as x squared plus 6x plus 9 minus 9 plus 5. The bracket becomes x plus 3 squared and the constants combine to minus 4. So the vertex form is x plus 3 squared minus 4. You can check quickly. Expand x plus 3 squared minus 4 and you'll get x squared plus 6x plus 5 again.
That's neat. The vertex is at x equals minus 3 and y equals minus 4 straight away.
Exactly. Now a trickier but common case where a doesn't equal 1. Example, 3x squared plus 12x plus 7. First factor 3 from the x squared and x terms. 3 times x squared plus 4x plus 7. Now half of 4 is 2. Square that to get 4. Add and subtract 4 inside the bracket. 3 times x squared plus 4x plus 4 minus 4 plus 7. The bracket becomes x plus 2 squared minus 4. Multiply back 3 times x plus 2 squared minus 12 plus 7, which simplifies to 3 times x plus 2 squared minus 5. Notice how the add and subtract happens inside the bracket, and that when you multiply back by 3, you must adjust the constants. That's the arithmetic step most students mishandle.
Why does this work? Because we are creating a perfect square trinomial inside the bracket. Factoring a first keeps coefficients neat and avoids fractions until you need them. If you did not factor a, you take half of b directly and end up with fractions inside the square. That increases the chance of sign errors.
So the careful order is factor a, half the inner coefficient, square it, add and subtract inside, then expand constants back out.
Precisely. Let that sink in. Now, the exam technique, how marks are awarded and how to write it to capture them. For a standard vertex form question, you'll typically see marks split like this. M1 for factoring the leading coefficient or starting the correct method, M1 for adding the correct square term inside the bracket, M1 for handling the constants correctly when you multiply back, and A1 for the final correct vertex form. If your working shows the correct intermediate method, you'll often pick up method marks even if a small arithmetic slip occurs.
Tip: write each algebraic step on its own line. For example, line 1, factor the a. Line 2, show the half and the square you add. Line 3, show the bracket as a perfect square and the constant adjustment. Final line, simplified vertex form. Examiners read vertically. They want to see the method, not mental jumps. Write it down, don't just think it.
What about partial credit when solving equations or sketching graphs?
Good question. If the question asks you to solve ax squared plus bx plus c equals 0, completing the square can give you m1 for the rearrangement and m1 for forming the squared term, then a1 for the correct roots. For graphing, the examiner wants the vertex coordinates clearly labelled. Showing the vertex form directly often wins full marks for the transformation part. Always circle your final answer, and if solving, show the substitution steps for the square root. That'll protect you from losing final accuracy marks.
The quick win, a 10-second sanity check you can use in the exam. After you reach ax plus p squared plus q, do 2 fast checks. First, expand the first 2 terms in your head to check the coefficient of x matches the original b. In practice, compute 2ap and confirm it equals b. Second, plug x equals 0 into your vertex form and confirm the constant matches the original c. That is, check c equals ap squared plus q. These 2 quick checks catch the sign and arithmetic slips that cost most marks. So, in 10 seconds, verify 2ap equals b and check c equals ap squared plus q. I can do that under exam pressure.
Exactly. Don't skip the check. Now the outro, 1 quick recap and the call to action. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.
Bonus practice walkthrough, exam style, at speed. I'll work through one question and tell you where to write each step for marks. Question: convert 3x squared minus 18x plus 11 into vertex form. Ready? Step 1. Factor 3 from the x terms. 3 lots of x squared minus 6x plus 11. Write that as your first line. That's M1 territory. Step 2. Half of minus 6 is minus 3. Square that to get 9. Add and subtract 9 inside the bracket. 3 lots of x squared minus 6x plus 9 minus 9 plus 11. Show the arithmetic 3 times minus 9 so the examiner can follow the constants.
Step 3. Bracket becomes x minus 3 squared minus 9. Multiply out the constants. 3x minus 3 squared minus 27 plus 11, which simplifies to 3x minus 3 squared minus 16. Final line, 3x minus 3 squared minus 16. Circle the answer and quickly check. 2ap equals 2 times 3 times minus 3 equals minus 18, matches the original b. Plug x equals 0, ap squared plus q equals 3 times 9 minus 16 equals 27 minus 16 equals 11, matches the original c. Marks collected, time saved.
That felt like an exam run-through. Seeing where to write each step makes a difference. That's your practice task done. Final sign-off. If you want 50 fully worked solutions covering every topic we discuss on the show, plus a downloadable practice sheet for completing the square, visit jcacademyonline.co.uk. Share this episode with a friend and keep practicing under timed conditions. Stay curious.